times x. Okay, it's direct because since y and x are both in the numerator, if you double x, it'll double y. If you cut x in half, it'll cut y in half. Basically, if one gets bigger, the other gets bigger. If one gets smaller, the other gets smaller. They vary directly. That's what is called direct variation. And we have seen this. This was in section 2.3. We did this right after we did all the review stuff about straight lines, and we compared it to y equals, look at this, y equals mx plus b, right? I mean, a direct variation is linear. It does not have a y, the y-intercept is 0, right? That's why you don't see a term after that. And instead of using m for the slope, we're using k for the slope. But other than that, it's a straight line. So this book will say almost exclusively, varies directly. But it's important for the SOLs and even on the SAT that they're probably not going to say varies directly. They're going to say is proportional to or is directly proportional to. They all mean the same thing. It means you're starting with y equals kx. So inverse variation, also not new. We did this. We did the graphs of inverse variations at the very beginning of the last chapter. It's y equals k divided by x. So now, because the x is in the denominator and the y is in the numerator, if you increase x, you decrease y. If you decrease x, you increase y. They vary inversely. Okay? And the book will say, almost exclusively, varies inversely. The SOLs say is inversely proportional to. They still got that word inversely. It'd be hard not to recognize what they're trying to describe. Right? The k in either case, right? This k is a constant, meaning it does not change. X and y change. They're variables, but k does not change. It's a constant. And it's either called the constant of variation by the textbook or the constant of proportionality by the SOLs. That means the same thing.